Welcome to Brain Bites. Okay, picture this. You're looking inside a laboratory, and scientists are meticulously watching 360 cockroaches eat. I know, not exactly your glamorous high-tech science experiment, right? It's a pretty bizarre, honestly, kind of gross visual to kick things off. But what these researchers figured out just by watching these bugs chow down, it's going to completely shatter everything you thought you knew about human hunger, the aging process, and exactly why you might suddenly want to demolish an entire bag of chips right after finishing a supposedly massive meal. In this explanator, we are diving deep into the absolute wild biology of how our bodies are literally hunting for protein.
So to really get to the bottom of human hunger, two scientists who actually literally wrote a book called Eat Like Animals spent decades researching appetite, and they decided to start with the ultimate biological survivalist, roaches. They basically tracked the bug's normal baseline eating habits and then split them up into 24 different highly specific diet buckets. Now the genius part here is that they tightly controlled the macronutrients. They separated out the proteins, fats, and carbs into these specific buckets to see exactly what was driving the cockroaches to eat. Once the buckets were set up, they just let the bugs go to town and eat as much as they wanted from their assigned groups.
Now, what's really interesting about this slide is the profound biological law they stumbled onto. The cockroaches in Group A, the ones given a high-protein, low-carb diet, they ate exactly what they needed and then just stopped. They maintained their little bug weight perfectly. But Group B, the guys on the low-protein, high-carb diet, they just kept eating and eating and eating until they got completely fat. Literally, fat cockroaches. It's a crazy concept, but the researchers spent the next 30 years replicating this exact same phenomenon in mice, dogs, monkeys, and eventually us humans.
And this brings us right to a foundational concept that stretches across the entire animal kingdom. It's called the protein leverage hypothesis. Basically, this means that you are biologically hardwired to overeat total calories until you hit a very specific minimum protein quota. So think about it. If you're mindlessly snacking on potato chips on the couch, your body is fundamentally acting just like one of those roaches. Your biology is literally forcing you to hunt for missing nutrients, and it is going to keep your appetite switched completely on until it finally finds them.
To visualize exactly why this happens, it helps to think of your body as this massive, bustling construction site. The site manager is constantly screaming for bricks, which, in this case, is protein, to rebuild the walls. But instead of bringing bricks, your diet just keeps sending the workers electricity, pure energy in the form of carbohydrates and fats. Well, the workers have all this energy now, but they still literally cannot build the wall. So what happens? The site manager just keeps calling for more and more deliveries. They'll demand truckload after truckload of food, just desperately hoping that some bricks eventually show up hidden somewhere in the pile.
The biochemistry happening behind the scenes here is absolutely fascinating. See, protein uniquely contains these really complex nitrogen bonds that are super tough for your body to break down. This naturally slows down your digestion. But it's not just about having physical bulk sitting in your stomach. It actually sends a powerful chemical signal. As that protein digests, it triggers a cascade of satiety hormones in your gut, primarily one called GLP-1. And get this, that's the exact same stop eating signal that those blockbuster weight loss drugs are artificially replicating right now. Protein does this totally naturally. It travels right up to your brain and says, hey, we have the structural materials we need, we're full, stop eating. But if you just eat refined carbs, that strong GLP-1 signal simply never gets sent.
And right here is where the biological trap snaps shut. Human bodies are incredibly efficient at storing excess electricity, the extra carbs and fats. We just pack them away in batteries for later. We call that body fat. But you literally do not have a storage mechanism for protein. There's no protein reserve tank. Whatever amino acids your body doesn't need for immediate repair right in that exact moment, they're simply broken down and the nitrogen gets excreted right out through your urine. So because you absolutely cannot store protein for a rainy day, you're forced to consume it continuously.
So the crucial point is, when this underlying biology crashes head-on into our modern cultural eating patterns, it creates a massive public health crisis. The data is frankly staggering. When looking at traditional diets, particularly in places like India, the average person is consuming only about 0.5 to 0.6 grams of protein per kilogram of body weight per day.
Now, you might look at the official World Health Organization guidelines, which suggest 0.8 grams, and think, okay, well, we aren't too far off from that. But modern nutritional scientists basically consider that WHO metric to be severely flawed. It's actually based on these really outdated nitrogen-balanced survival studies from way back in the mid-1900s. They were only measuring the absolute bare minimum required to prevent severe malnutrition. Basically, 0.8 is the please don't die number. It is definitely not the thrive number. Modern clinical guidelines show that adults actually need somewhere between 1.2 to 1.6 grams of protein per kilogram of body weight just to maintain optimal health and actually protect their muscle mass.
Let's just do the math on a traditional vegetarian diet really quickly, like a standard Indian thali. People often assume they're getting plenty of protein from wheat rotis, but check this out. To get just 10 measly grams of protein, you'd have to eat roughly 9 rotis. What about dal? Sure, uncooked lentils have protein, but once they're boiled down with water, oil, and spices, a standard serving gives you maybe 6 or 7 grams. When researchers actually break down a standard meal, a couple of rotis, some dal, sabzi, maybe some yogurt, you might scrape together 20 grams of protein. But that comes packaged with up to 1,300 calories. Mathematically speaking, it is virtually impossible to hit your optimal protein targets this way without consuming a massive amount of pure carbohydrate energy alongside it.
But wait, why do we even need so much protein in the first place? Well, it's because your body isn't just some static piece of architecture. Right this very second, your body is actively tearing down and rebuilding its own tissues. Every single day, the average human body goes through roughly 300 grams of protein turnover. 300 grams! Even the biggest bodybuilders aren't eating that much protein every day. Now, the body is smart. It recycles old cells to harvest their amino acids, but the recycling process isn't flawless. You lose some along the way, and that deficit absolutely must be replaced by your diet so you can keep building vital enzymes, hormones, and immune antibodies.
Okay, let's dive into this. Because since we don't have a storage tank for protein, we face a pretty dark mathematical reality. If you are only eating, say, 50 grams a day, but your body absolutely needs more than that just to keep your vital organs functioning, well, it only has one place to go looking for it. Your body literally looks at your biceps, your quads, your back muscles, and says, look, we need amino acids right now to keep the liver and the heart running. Break down the muscle tissue. If your diet is deficient, your body literally cannibalizes its own muscle just to survive. It is a completely terrifying truth.
So, if our bodies are out here eating our own muscles, why in the world aren't we all heavily prioritizing protein? Well, it mostly comes down to arguably the most destructive dietary myth of our entire generation, this lingering fear that eating protein is going to destroy your kidneys. And this whole thing actually stems from a classic scientific error called reverse causality. Decades ago, doctors noticed that for patients who already had chronic kidney disease, meaning their kidney filters were already broken, a high-protein diet caused waste to build up faster. So understandably, they restricted protein for those really sick patients. Makes total sense, right? But then came this massive, totally false leap in logic. People started assuming that because processing protein stresses a broken kidney, it must therefore cause a healthy kidney to break in the first place.
Taking extreme dietary restrictions meant for sick, hospitalized patients and blindly applying them to completely healthy, active people is a profound logical fallacy. It's exactly like saying, hey, running on a broken leg makes the break worse. Therefore, running causes your legs to break. It's totally backward. It completely ignores how healthy biology adapts to stress. When you feed a healthy kidney more protein, it undergoes a process called hyperfiltration. It safely adapts to the workload. It's basically getting a workout, not getting damaged.
And look, this isn't just theory. It has been tested to the absolute extreme. Dr. Elaine Norton and other top researchers have conducted these gold standard trials looking at heavily muscled individuals who are consuming a staggering 4.4 grams of protein per kilogram of body weight. Guys, that is a comical amount of protein. It's almost 4 times the optimal amount. And the result? Absolutely zero kidney damage. None. Their kidneys functioned perfectly. There's literally zero evidence that a high-protein diet damages a healthy kidney.
And this brilliantly illustrates the real danger here. Avoiding protein out of this totally misplaced kidney fear leads directly to a terrifying reality as we age, something called sarcobesity. It's this lethal combination of 2 colliding conditions. Starting around age 20, yes, 20, if you aren't actively eating enough protein in strength training, you naturally start losing roughly 1% of your muscle mass every single year. That's sarcopenia. Now combine that muscle loss with the obesity that comes from constantly overeating carbs because your inner cockroach brain is endlessly hunting for protein, you get sarcobesity. Weak, depleted muscles wrapped in highly inflammatory, dangerous, visceral fat.
We absolutely have to fundamentally reframe how we view muscle in our society. It's not just for athletes, and it's not just for looking good at the beach. Muscle is an organ of longevity. Think about it. After age 65, fatal falls become a massive threat to your life expectancy. If you slip on the ice or trip on a rug and you have robust muscle mass, that muscle literally acts as a physical shock absorber. It takes the brunt of the impact. But if you have wasted, depleted muscles from decades of eating a low-protein diet, your brittle bones are forced to bear the full force of that fall. Muscle is quite literally your physical armor against gravity, and it is exactly what saves you from life-threatening hip fractures in your 70s and 80s.
What makes this even more critical is this tragic irony of aging, known as anabolic resistance. Basically, as we get older, the cellular machinery inside us that builds muscle gets a little sluggish. To actually ignite the engine of muscle building, older adults require a much higher dose of a specific amino acid called leucine in a single meal. Yet, what do we typically do in nursing homes or hospitals? We feed the elderly plain porridge, a cup of tea, maybe some toast. We drastically lower their protein intake at the exact moment their biology desperately demands more of it to fight off that anabolic resistance. We are essentially accelerating their physical decline.
This is exactly why the top modern longevity clinics out there don't just test your blood anymore, they test your grip strength. They'll hand you a hand dynamometer and tell you to squeeze it as hard as you can, because the force of that squeeze can statistically predict how long you are going to live. A powerful grip isn't just about having a strong forearm. It acts as a highly accurate proxy for your total body muscle preservation and your overall neurological integrity. Retaining that physical armor proves that your body can survive the inevitable insults of aging.
Let's move to and see how this builds into one final, completely mind-bending fact. We talked earlier about your body's relentless protein turnover. Well, because of that continuous 24/7 cycle of tearing down and rebuilding, biological tracking shows that your entire arm is essentially rebuilt with brand new cells every 90 days. Think about that for a second. Down to the microscopic cellular level, your body completely rebuilds itself from scratch 4 times a year.
So here is the provocative question you really have to ask yourself right now. Look at your very next meal. What kind of raw materials are you giving your body to rebuild with? Are you constructing an absolute fortress of muscle and bone? Or are you building a fragile house of cards that's going to collapse the second life throws a physical challenge at it? Skip the pure electricity and give your body the bricks it's begging for. If you like this video, then please share with your friends and don't forget to subscribe to the channel.